La primera pregunta es, ¿cuál es la fracción de hidrocarburos más importante de monitorear en un humedal después de un derrame de petróleo?
There's a lot of different ways to measure the hydrocarbons. You can look at total petroleum hydrocarbons, or TPH. The TPH value can be done relatively cheaply. It's an inexpensive test, and it's a fast test. As a toxicologist, I don't like TPH values so much because it doesn't tell me a lot about potential impacts. It gives me a good indication of what the general hydrocarbon level is, and what I use a TPH analysis for is an early warning sign. I can do the fast kit level TPH analyses, and if I find a high value, then I can go back and do my more robust test, which is polycyclic aromatic hydrocarbons, or PAH testing. That's usually done in a laboratory. It takes a little while to get the results back. It can be fairly expensive. But the most important analysis that you can do is the fingerprint of the PAH fingerprinting. And what that is that's a very high resolution analysis. The typical PAH test will give you anywhere between 16 and 32 congeners of the aromatic hydrocarbons. The fingerprint gives you about 210, and it also gives you the degradation products. And what that tells you is what the source of the oil looks like and how weathered that oil is. So if I'm doing a spill response to a spill, what I want to do is two things. I want to measure the hydrocarbons in the water and in the area where it's been released. I want to measure it before the oil gets there so I know what the background levels are. And the most important thing is to get a sample of the oil that's been spilled, because that's the fingerprint that you're going to match against everything else. It's just like DNA, and it can be used to identify different oils from different pipelines running next to each other. And we've done that before too. So we can identify oils that have been released. In fact, there was a spill in San Francisco Bay where oil balls were washing up on shore, and nobody knew where these were coming from. And so we collected those, had them fingerprinted, and then all of the ships that went into the port, all of their bunker oils were tested. We were able to identify which ship was dumping illegally their ballast water offshore because that fingerprint matched exactly to that ship. And so it's a very, very valuable thing. It's very expensive, and there are very few labs that can really do it well. There's several labs in the United States that can do it. There's a few labs in Europe. I don't know the lab situation in South America. I'd rather doubt there's anybody down maybe outside of Brazil that might be able to do it, but I don't even think there's one in Brazil. I think everybody sends their stuff to Texas to have it done. There's a lab in California, there's a lab in Texas, there's a lab in Washington, D.C. that can do it very, very well. And there's a lab in England that does it. But I've got projects, spills that I've responded to in Western Africa, in Australia, and everybody sends their stuff to these labs. So they tend to be slow because they have a lot of stuff going on. Okay.
La siguiente pregunta es, ¿cuáles son los límites permitidos de TPH y PAH en los humedales?
That depends on the jurisdiction. California has a different level that's required than Florida does, than Texas does. Each area is different. What we're struggling with at this point is looking at threshold levels of hydrocarbons that actually cause damage and toxicity. So I've seen values from 10 parts per million to 400 parts per million of PAHs, total PAHs. But it depends on the jurisdiction that's regulating it, and it depends on what the target species is. Because if I'm trying to protect plankton, my value is going to be much less than if I'm trying to protect adult fishes. So it really depends on a day-to-day situation. But there are good groups out there that have a lot of this data online. for that kind of a question. And one of the groups is the Society for Environmental Toxicology and Chemistry, or CTAC. And the website's ctac.org. That's cetac.org. That's a very good resource to be able to get some of that information, but it really depends, and it's sort of site-specific and regional specific. I know Australia is different than the United States, and places in the US are different. So it's a hard question to answer directly.
Siguiente pregunta es, ¿cuál es el proceso que sufre el petróleo con la aplicación de dispersantes y en cuánto tiempo se produce su degradación?
Yeah, that's a good question, because a lot of dispersants, the actual chemistry is not well known by a lot of people. What the dispersant does is it breaks up the cohesion of the oil molecules. So the oil generally wants to stick together and form a big slick. And what the dispersant does is it tends to break up the oil pieces and separate them so they become much, much smaller. The smaller the droplet, the more easy it is to degrade naturally. The more easy it is to be degraded by bacteria. But at the same time, the smaller the droplet, the easier it is to be picked up by organisms. So you have a delicate balance between use of the dispersant to break up the slick, because the damage that a cohesive oil slick does is much more than the damage that's caused by the tiny little particles, because it takes a lot of time for a big slick that's undispersed to weather and break up than it does to take that dispersed slick to break up. There's also issues with what kind of dispersant you use, because some of the dispersant chemicals themselves are toxic. So you're spraying essentially a toxic chemical onto an oil spill to break it up to cause less damage. Again, it's a balancing act where you're trying to avoid longer-term impacts from an intact spill hitting something. You're trading off some short-term impacts from use of the dispersant. So in my opinion, as a toxicologist, I think the dispersant idea is very, very good if it's used correctly. If you just spray dispersant on every little spill that's out there, you probably do more damage. But on a big spill like an Ixtoc or a Deepwater Horizon or Exxon Valdez, the dispersants would work really well. Now, the reason dispersants weren't used in Exxon Valdez to a great extent was because it was too cold. It just didn't work up there. So it works really well in warm environments. So in this environment, in this part of the world, it would work really well, but not in Alaska.
Siguiente pregunta es, ¿cuáles fueron los errores de planeación que se presentaron en el último derrame del Golfo de México y cuáles fueron las lecciones aprendidas?
The mistakes? Okay. Well, I think that there was a couple of big mistakes that were made, in my opinion, of what happened. And one was one of the key things for the Incident Command Center is also outreach and information transfer. And the responsible party and the resource agencies that are involved have to have transparency with the information that they have. And it took a long time after the Deepwater Horizon spill happened before complete transparency with what was going on happened. Part of that was because of the large nature of this spill and a lot of different people out there. Part of it was also because there's the liability issue of how much oil was being released has a specific requirement in the United States for overall liability. So nobody knew, and nobody wanted to guess until we really knew how much oil was being released. So that was a problem, and that I think led to credibility issues with the public. And so I think the biggest lesson that I've told a lot of oil company CEOs that I've talked to is transparency, transparency, transparency from day one. Get out ahead of it and do that. I think the other big issue was we didn't have real good data on the background, that environmental baseline of the spill. So it wasn't really a response issue, but it was really a damage assessment issue. We didn't know how much damage there was because nobody knew what was there to begin with. So that was an issue when the permits were set. The environmental baseline data was essentially 4 or 5 samples, and that's all that was ever required. And now that's very different, but having that environmental baseline, I think, is really, really important to be able to get out ahead of that.
La siguiente pregunta es, ¿la diferencia entre el caso de Nigeria y del Golfo de México se debe a fuertes regulaciones y a una agencia ambiental muy estructurada y con recursos?
Yes, I think that has a lot to do with it. It also just has to do with the fact that the situation in Nigeria, the governments are very fluid there. So they've changed a number of times. There's a lot of different factions. There's, like I said, 40 different ethnic groups that all have still a very tribal aspect of the way that the areas are governed. So there's no real central, strong resource agency that controls everything. In the United States, everything's controlled by the federal government and the states. So there's a very good thing. Resources certainly have a lot to do with it, although I would argue that Nigeria has a lot of resources, monetary resources from the amount of oil that's been produced. It's just those resources haven't gone back into spill prevention or spill planning or resource agencies. They've gone other places.
Siguiente pregunta es, aquí en Colombia es más fácil obtener una licencia de exploración y explotación de hidrocarburos que una licencia de colecta e investigación biológica. ¿Cuál es su opinión sobre el hecho de que esto pueda convertirse en un escenario donde la exploración de hidrocarburos sobrepase la capacidad de poder conocer y estudiar nuestra diversidad para conservarla?
Well, I don't know I can't really comment on the process that takes place here from a standpoint, but I think having a strong agency that can build that impact assessment, planning, mitigation up front, I think is going to be vital to being able to maintain the resource and effectively exploit the resource to the benefit of the country and not just run individually. So I don't know how you get a permit here, but that I think is something that needs to be developed, is having that strong resource agency and the permitting process that goes through. The issue of research, I think, is very important. There's a lot of research on oil effects and oil toxicology that's applicable to this region. Having the resources and the folks to be able to utilize that is important, and having that is something that needs to go through both the academic world here in Colombia, but also in the agencies and the private sector as well. So I think the agencies and everybody needs to fund that kind of work.
¿Puedo opinar un poco respecto a esto? Sí. Disculpen que me interponga frente a la pregunta, pero es una pregunta que como colombiano me parece particularmente pertinente, y después de haber oído la presentación de Paul me parece preocupante. Y pues quisiera decir un par de cosas. La una, que algo que él mencionó respecto a la carencia de información de línea base frente al estado de los ecosistemas, respecto al estado de los ecosistemas de humedal, puede convertirse en un problema grande a la hora de la mitigación y la remediación. Si no tenemos información de qué son los ecosistemas antes de impactarlos, una vez se impacten, va a ser muy difícil desarrollar acciones de mitigación. Entonces, la investigación respecto a qué son los humedales de Colombia y cómo funcionan es urgente, y tiene lamentablemente en muchos casos el problema que la pregunta señala. En este momento es una gran controversia en Colombia el otorgar permisos de investigación científica, sobre todo en biodiversidad, y esto limita la construcción de línea base. La segunda cosa que quisiera decir es que este evento a mí me parece bastante singular en el sentido de que es convocado por el sector de hidrocarburos y no por el sector de biodiversidad, y por eso Me parece una oportunidad única y feliz de que de repente de la mano el sector de hidrocarburos con el sector ambiental pudiera ayudar a ejercer un poco de presión para que Colombia construya una línea base sólida respecto a su biodiversidad con el fin de prevenir los impactos negativos de distintos procesos extractivos.
Nos quedan un par de preguntas. ¿Quién administra o organiza estos mitigation banks?
It depends on the state. In California, it's managed by the California Resource Agency, which is the overarching, essentially California Environmental Protection Agency. At a federal level, it's generally managed by the National Oceanic and Atmospheric Administration, NOAA. So it depends on who's setting them up. Once they're set up, they're always set up by the agency, but they're also set up by the stakeholder groups as well. So all of the project proponent, the responsible party are going to do this, but the resource agencies and the NGOs help decide what projects will be used for that mitigation bank.